In this video, we're going to look at the heating curve of water. And what this graph shows us is the relationship between the temperature of water, in this case, and the heat that's added to it. So if we were to add heat to water below 0 degrees, it would be in the solid state, and the temperature of that solid would go up. And at 0 degrees, it would transition into a liquid, but the temperature would stay the same, and it would plateau until all of that liquid solid melts. And then once all of the solid melts, then that heat energy will go into raising the temperature of the liquid until it reaches 100 degrees Celsius, at which point that heat energy will go into converting the liquid into a gas. And once all of that liquid has boiled away, then the heat will go into increasing the temperature of the gas. So there's 3 slopes here, and those slopes can be identified as a solid, a liquid, and a gas. The plateaus indicate phase change, and the first plateau is a phase change between a solid and a liquid, and so that will be the melting point or melting phase transition, and that temperature, the melting point, is going to be 0 degrees. We've also seen the word fusion as well. The next phase transition is between a liquid and a gas, and that will be the boiling point. And so we can use any substance to tell what the boiling point is just by going over. And in this case, as we know, the boiling point is 100 degrees Celsius. So you can also look at this in terms of kinetic energy, and we talked about how kinetic energy is the energy of motion and reflects the temperature of substances. So the kinetic energy also goes up as heat is added, and the kinetic energy does not change at the plateau until all of the substance has melted. And again, it goes up, and as a liquid, once it starts boiling, it doesn't change. Kinetic energy does not change until all of that water is boiled and it goes into a gas phase. A cooling curve would be just the opposite of this. So you will be looking at the cooling of lauric acid in lab.